What's up, everybody? My name's Kevin Toppenberg. These are my neighbor's alpacas. Today we're going to work on the x-axis of the mill, which is the left-right, and specifically the left side where the crank is. And we got a part to make for that and to get that all together. I'm also going to show working on a power feed. And this is going to be a little bit different in that ultimately it is not successful. So if you don't like to see work done on something that doesn't ultimately succeed, then you'll want to skip that part. But I think there can be some value in just seeing the process of going through and maybe also seeing what they look like on the inside and just, learn from my mistakes. Hope you enjoy the show. If you like it, give it a thumbs up and some comments, and hope you enjoy. Let me show you the situation I have. These bearings can just slide out. So there's this bearing retainer. This goes on here, and this inner flange is going to push up against that outer race of those bearings. And normally you put that in, and then there's a cap head screw that goes in there and fastens into that. But someone has been working on this in a bad way. If you notice, cap head screw goes in here nicely. That's fine. But look at here, completely drilled out. And furthermore, on the other side, we've got this. The screws that came out of there, this is what I have in my bag. I had 2 bevel heads and 1 cap head. So it's almost looked like someone flipped it around and did that, maybe because they didn't have a cap head screw. I don't know, I don't like it though. So I think I'm gonna remake this part. So I dig through my stock of some aluminum, and I have this, which would work, but I also have this, which is just a hair small. So this is like 4.95 in diameter. This is 4.85, so like 10 thousandths shorter. But the inner diameter of the place where it goes is like 2.99. And so I don't think it matters. It doesn't matter how tight this fit is. In other words, it can wobble in there. But all it has to do is push in on those bearings and then bolt in. So I think being 10 to maybe 20 thousandths short. Let's just look. That's 2.918, and that's 2.845. Yeah, maybe like 60 thousandths less. Furthermore, this has a cut into the side, but if I look at the thickness here, that's 450 thousandths, and this thickness is 453. So I think that I can use this piece. So I'm gonna have to remanufacture that. So I have this on a mandrel. I'm just taking it down. It initially was wanting to spin, but I got it tightened up good enough now that it seems to be cutting okay. I'm using a carbide tip. I don't remember if that's a bad thing to do with aluminum or not, but it seems to be cutting. I have to kind of pick the aluminum that sticks on the end, a little chip welding, but otherwise it seems to be doing okay. I've got it down to 507 or 8 thousandths there. Got just a little bit of that residual of that cut. I'm gonna try to get that out, and that's where I'm gonna stop. Okay, I've got this part done. I have 100 thousandths shoulder there, just like the original part. The diameter is wider than the final diameter. And the reason for that is I've got to now take this off this mandrel and put this in a 4-jaw. Well, I might see if I can do it with a 3-jaw, because the center hole I don't think is super critical. So I might be able to get away with a 3-jaw. But then get that mounted in, and then I got to take out the center part, and then I want the center hole and the outer hole to be concentric. So that's why I'll then get the final diameter on that. Okay, I just flipped that around and faced it off. Nice and shiny. I'm going to use my S&H style drills to take out that center material. I've got it back flush against the face of the 3-jaw. I've made sure that there's clearance behind that for where we want to take out. So let's get started. All right, I'm going to step that up through the various sizes. I'll bring you back in a minute. That's my largest drill, 1 inch. Got through there, now we need to get a boring bar. Very thin. I'm gonna try to take that all out on this next pass. Okay, let me show where I am on this part. So this part goes in here like this, and it fits just inside the recess for that bearing, and then it puts pressure on that outer race of the bearing, like that. I decided that I would go a little bit thicker. Now that race, that outer segment of the bearing is higher than in between here. So as long as I don't go all the way to the inner part, it doesn't matter how thick it is, and I think it'll give it a little bit more strength. So I've got that on there, and that fits in there very nicely. I want to think out loud for a little bit here. If I put this part in here, that's the retainer for the outer part of the bearings. And then if I put this on, if you notice, there's a gap there. So this part here is holding the bearing relative to the table, and the inner part is holding the inner part of the bearing relative to the shaft. And I don't know whether it's critical for that to be there, whether there's a gap or not. I made a flange to go in and take up that gap, but as I'm editing this video, I think probably it wasn't necessary. I'll include the footage here just because I did it at the time, but I don't actually think it was needed. Then I just started looking around to see what parts I had. I just had picked this up somewhere, and it just so happened that it goes on like that. And there's a rim where that thing is worn down, keeps it from going in all the way. So that was very convenient. Trying to find a way to locate these so I can transfer the holes. That on there. And then this thing's wobbling around, and I found this, and it was pretty much almost exact. And then that went on there like that. So that got those things lined perfectly, or perfectly enough. And then I put this, I got that brass part lightly pinched in the vise. I then took a transfer punch, put it down in there and made a mark. And then I rotated it. And then although I can't use a full transfer punch here because it interferes with this, but I was able to visually get that lined up and then make my second mark and then rotate around and make my third mark. It's hard to tell with the parallax of the camera, but just to my eye, they look like they're all in the center. So now I just need to drill those out. Okay, I've already drilled one hole. This is a very old, worn out drill press. My poor excuse for a mill. Got this, I think it's a spotting drill, either that or it's made for counter setting. This machinist vise is better than nothing, but the gibs are not, the ways are not parallel, and at some points in its travel it's smooth, and other points it's very tight. All right, got a nice started hole there. My target size is gonna be 1/4 inch, but I just grabbed something that was smaller. All right, now this is my 1/4 inch bit. And then lastly, I have a 3/8 inch 2-flute end mill. This happens to be carbide, but it doesn't matter in this case since it's such soft metal. Now the whole piece there is something like 320 thousandths. So I am drilling my hole for the countersink 150 thousandths deep. And this thing shake, rattles, and rolls, so it's only approximate. 50 thousandths, 100 thousandths, 150. It's scary because I didn't want to go all the way through. That's as deep as I dare go. Those things are they're only raised up a little bit. I think that'll work well. And I'm gonna do the third one off camera. And it's done. I'm kind of proud of it. I think it'll work real nice. But guess what I'm not proud of? And I told myself I wasn't gonna do this. I put the countersinks on the wrong side. I can still use it. It's just the bolts are gonna stick up on the top. Like a chump. Here's the good news. The bolt holes were right, it went in. And here, my gauge, look at that. All of that mistake is hidden. All right. Also, I don't know if it'll show here, but when I come in here, I'd say there's like 1/1000th or a 1/2 gap between here and that piece, which means this is hitting the spindle first, which is exactly what I wanted. So I'm very happy with that part. Just not the bolt heads and the countersink, but it'll be all right. Guess what? I think I have the lead screw in backwards because when I put all of this on and everything's in there properly, this does not come out far enough for the key to engage with that. So I think the other side is a little bit longer. So I will try putting this on there. Actually, I can just try that right now. Yeah, see there's room for the handle. Like that. This unit hooks into the power feed, so I think that must somehow go to the other side. So it's not a big deal. I just have to unscrew that, flip it around. But I don't know if you can see the clock over there. It's 11:30 at night, so I am going to bed. Okay, today's a new day. I had some rest, thinking a little bit more clearly, and let me see some changes. Let me show you some changes I've made. First of all, about this lead screw, the journal on this side is longer than the journal on the other side. So I got to thinking and thought that this was in here correctly, but actually I just turned it and just screwed it in so that it advanced more, and that turned out to be the solution. So now it's sticking out farther. Just needed to change the relationship between the two. I then cleaned up this thread and the nut, and I spent a fair amount of time trying to debate with myself whether to remake this part. After all, I don't have a good block of aluminum. I could make it out of this, but I really hate to waste all of that when I think that this probably is good enough. So one thing I was concerned about is that the next person was going to be very confused about why there was these countersinks on the wrong side. So I got my letters out, these, and stamped oops on each side, or each one, and then I put outward on each of these. Hard to get those exactly straight, but I think the message will come through. So I'm gonna go ahead and put that back in and get it all tightened up. Here I have it all back together. This nut was not going on to the end very easily. That nut is a 1/4 inch 20 thread, which is fine. So I ran a tap through that and I ran a die on the threads on the lead screw. And now it goes on nicely. I wire wheeled this. There's still, you know, dings and stuff, but I think that's okay. So it looks good. I've tested. It has 23 thousandths of backlash. I can get access to, it's not really showing up there, but I can get access to that tightening area back in there. You gotta have a really long screwdriver. I have one, but it's down at Knox Maker, so I may do that later. And then last quick thing, I just wanted to review for anyone that doesn't already know this, but this part right here just runs loose on that journal in there. And then this nut is what tightens up, and that allows you to adjust your scale so that you can, re-zero it out. And so that just tightens up against there. This nut has nothing to do with tightening it onto the lead screw itself. That all comes from here. So I got that all tightened up, got these on, And this side is done. Okay, I want to quickly show the spindle holder for the right side of the table. I just cleaned it up a little bit. I found it inside the column because they've replaced it with a power feed. Of note, this bearing here, they just have one bearing instead of two. It's a little bit bigger bearing, a little bit thicker, I should say, but they only have one, even though it looks like maybe it's designed for two smaller ones. Also, you know, has this and this like the other side, but it also had these little shims, and then it had this, which is the same diameter as that. So apparently there was some spacing issues. I don't quite understand what all that is about, but I'm just going to put this back into storage in case the power feed breaks, and I just want to put it back to the traditional way. One other quick difference of this right-sided holder is that it does not have screw holes where a plate, this is from the left side, where that could be fastened in. So I don't understand why that is either. Anyway, I'm sure there's a reason. Okay, I've made a mess with all this aluminum, and I'm going to try to get cleaned up here a little bit. This has really been the first good use of my chip tray, and boy, I'm happy it's here and not on the floor. Well, I know it's a little bit OCD of me, but I feel a lot better when I got everything clean. I got this workbench all cleaned off. I got my lathe cleaned off. I did and I got my drill press cleaned up, got my floor swept. I just feel like it leaves like an empty, clean area ready for more work. Okay, so I've got a couple coats on here. I'm going to, I don't know that it's completely dry yet, so I'm going to gently get those mounted back on, and then they should dry over the next 24 hours. I'll bring you back after I got that done. That's how it looks back on. I think it would have been fine the way it was. I think the metal was fine, but the other side was aluminum and had been painted, and it wasn't the right color. So I was gonna have to paint that side, and then I would have one side painted and not the other. So I just went ahead and painted, and I think it actually leaves a nice accent. Okay, here's a first look at my power feed. It's fairly heavy. I don't know if that's an indication of the quality or not. The on and off switch here seems to be broken, just wiggling, and then I can't actually get it to move. And I've got it plugged in, and I'm not getting any motion when I go forwards or backwards. Okay, I've gotten it cleaned up, used some simple green, and I think it looks better. I'm a bad one for wanting to put lipstick on a pig. We don't know whether it's gonna be a pig or not, but I will say that I had it plugged in because I tested it, and I was cleaning it up, and as I was cleaning, then suddenly this switch, which again I think is broken, suddenly changed, and the GFI blew there. So I'm like, that's strange, and I reset it. And then I said, well, I wonder what's going on. And I pushed it and it blew it again. And now I can't reset it. So I don't know whether that was some really high current that was shorting out, or whether that thing just needs to cool down. I'll have to come back and check it later, but this thing may have some serious problems. I'm going to use this as an extended recording of taking this apart, just in case there's complicated pieces, and I don't want to forget how it went together. I spent a long time, as in a couple of weeks, trying to repair a really old power feed on my first mill restore, and I mapped out the circuits. I tried repairing the circuit board. Thought I had everything just right, got replacement components for the parts that I thought were bad, got it all done, connected it to power, and poof, out came the magic smoke. And I said, forget it, get a new one. On first inspection, I don't see anything grossly broken. So that screws off. Again, that doesn't feel healthy. So I'd like to be able to get that out of there somehow. It's got this board here, or this protector. All right, well, maybe the circuit board disconnects here. Let's try that. So this mounting here seems to be one piece with the casting. This switch is going to have to go in which means that this motherboard needs to be removed. I think I see one mounting screw down there. There is still something holding it. I see one more plug down there. And that's a protector to keep the things in the bottom of the circuit board from touching the aluminum. And with that, it comes out. And when I look here, both of these resistors are loose. So that doesn't seem good at all. I don't know if it would be as simple as that or not. Okay, I think there's a ring under here. So I need to take this plate off, and to take the plate off, I'm gonna have to take this handle off. I can't even see that hex nut, and it hasn't fallen out. And it sure felt like I had a nice fit to begin with. All right, well, there's my set screw that fell out. Just trying to pry between the base of the knob. Let's try screwing it. So it was just corroded. Oh, wait a minute, we got something down here. That's our secret right there. Okay, that feels quite loose. That should be plenty to have this come off. I'm just taking the set screw out. It's completely out, so I know that's not a factor. And it looks like there's kind of a wavy washer underneath it, because I'm guessing that's just pressed on there or screwed on there. You know what, I can get to that. I can get to this nut even without taking that completely off. That switch is definitely bad. It's got to come out of there. There's something that's keeping this plate from rotating, but I can't see what it is. Oh, there's some sort of a pin. That pin is the limiter. All right, well, that's not coming off over that. That has to just be pressed on there. Okay, so I got the nut off. All right, now I'm gonna work on getting this switch out. I think I'm gonna have to unsolder that right where it is. Okay, got it. The appendix. I don't know if that shows or not, but that's just all burnt. To me, that seems like there's a big short that is going on somewhere. And it just burnt up this switch. You can see that there's really no working parts inside there. I wonder what the short is when all the wires look pretty good. I'm gonna solder these resistors back in. I think I'm looking everywhere else. I don't see anything else that looks burnt or hot. So either this will fix it or it's outside my skill level. Okay, got it hot, pushed out the broken piece, pushed through the the remaining leg, and got it nicely soldered. All right, now I'm going to try to push through the remaining good leg. You know, those things are sticking out, and I think that they were mechanically interfering with something. I'm going to probably make a big mistake, and I'm going to put them down further, way farther down on the board. So I'm going to just take them out completely. All right, that leg is free. The reason seems to be that these resistors are slightly longer than they had planned for in the design of the circuit board. Decided to try to disassemble this motor. I'll show why in a second. 2 screws go in here and here. In the top there is a place where the wavy washer goes in first, and then that bearing. That screw would come all the way down through here and then screws into the casting down there. This rotor, just a little bit of a press of that bearing into the recess or journal down below. I just tapped lightly on this side from the bottom and it came out. And then this lifts up. I notice, I'm not going to zoom in right here, but on these wires, there looks like there may be like some darkness and like it got hot. When I check the resistance, you know, obviously it's a coil. but there's like no resistance between the red and the black wires coming in here. And so I'm concerned that there may be like a short in here, and maybe that's part of what was causing the problem. Not sure what I'm gonna do about that, but that's just where I'm at. I decided to put this back together. I put the ohms down to just R times 1 and calibrated it, and actually found that there was resistance, a varying resistance between these various wires. It wasn't just 0. So I think that there's no short in that wire. So I just put that back. I just don't understand why there was enough electricity going through that it was able to burn out my wall socket, that this thing didn't kick. Maybe it's a slower event. The spec sheet for the circuit breaker I have here talks about how long it takes for it to kick, time versus current. So let's say we had 600, it might take 1 or 2 seconds, whereas that thing might have blown in, half second. Okay, I've got some replacement parts. I have a circuit breaker and a switch. This is the old circuit breaker, and I didn't get it out and read it until after I'd ordered the new one, which was a mistake. But it reads 3.1 amps, and this one is 7 amps. So this will take twice as much current to blow. So it seems like I probably should order one that's like this. But for right now, I want to hook it up and see if it works. I've got that new switch in there. I've got I don't know what are these called, blade connectors. Got one of those underneath, and the wire has to trace underneath the bottom. It comes out on this side. Now this circuit breaker is a little bit bigger, so I had to drill this hole out, and then also to kind of get it to go in and around the corner, I ended up having to oversize that hole about 30 thousandths oversize, and then also had to burr this off. And then also, there was a screw right there that was sticking out that was keeping this cocked out at an angle, but I think I've got it there now. So I'm gonna try to get that mounted in. All right, I've got the switch mounted. I've got the connectors back on. Had to run this big wire, come up through here and then back around. And I've got the circuit breaker on. I've got the waterproof caps on. Now I've got to get the circuit board back in, assuming that it'll fit. With that, we may have to work it around, and then we'll see if the magic smoke comes out. I've slid the motherboard down in there. I went back and watched my video about taking it apart, and I think I have all the wires connected back again. I think I've got it. So this is going to be a spinning shaft. I remember now that there was a twisty tie that was holding this stuff together, and I think away from that shaft. So I think I need to get that replicated. I think I'm going to try to tie it into these bigger ones. Yep, that's going to keep that away from that spinning shaft. That will work. So this is going to be the switch for the rapid traverse and the power LED. Well, that's not awkward at all. Got to get that spring lined up into that hole, the recess up in the top of that shaft. Okay. Okay, got those two. Okay, here comes a moment of truth. And last time I tried this, I blew out my ground fault interact plug. So I'm going to try it over on this one, which does have a circuit breaker in it. Here goes nothing. Literally nothing. The power light is not even on. That's not what I want. I guess at least it didn't go poof. Guess what? As I'm taking this out, smoke is coming out. I guess there wasn't an exit port for it before, but now that the screw is loose, out's coming the smoke. Shoot. I think I saw the smoke coming from over here, so I'm wondering if it's not just the coil that's bad. Just gonna try to see if I can figure where the smoke is. I'm also don't understand why this circuit breaker didn't blow unless it's just too high current. I'll try turning it back on. I'm smelling some smoke, but I can't tell if it's this time or from before. I don't know. I went to look in here, and one of those resistors that I soldered back on had been pulled off, and it was stuck up underneath here. Kind of the same situation we had before. I thought I'd fix it by getting that closer to the board. I'm gonna take it out and look at it again. I'm kind of frustrated. Well, I found where the smoke was coming from. Right there. And you can see there's a little bit of dimple here. And there's nothing that would have shorted out that area. So I think it must have been from heat. And I think the heat must have been from the resistors, which means some inappropriate current was flowing, which means there's something somewhere. I think there's some sort of a short, and I think this is above my ability to fix. The mill came with this diagram for the power feed. If you look, this is an AL500P, and it's very helpful to give the circuit diagrams, except it doesn't give one for the one that I have. So I think probably it's gonna be, I mean, I've only spent like 20, 25 bucks now to getting the switch and the circuit breaker plus some time. It's probably better to just get another one. I'm kind of discouraged because everything else looks fine. I just don't understand what the problem is. But you know, I could buy, maybe send off somehow and get a new circuit board, but then if there's something wrong here, and it just shorts it out, because I don't see what else. All of the rest of this is just simple. You know, that's a potentiometer for the dial, and these are just simple switches. I don't see what else would do it. It seemed like it would just either turn on or not turn on. So the only thing I could think is that there's got to be some sort of a short in here letting excess current through. That's too bad. Well, folks, I have been working on the power feed that goes on this side. But I kind of think that's a side project. I don't even know if I'm going to be able to repair it. I may have to get a new one. Gosh, I'm looking at myself in the monitor. I'm filthy. Sorry about that. But I'm going to call the base done. You know, and there's always things that can be made better. I'm not super happy about the gap here on this. And we'll need to get the end stop mounted once we get the power feed. And I may end up wanting to get some sort of a protective thing here and all of that. But I think for all extents and purposes, at least for right now, I'm done. Again, I'm going to need to do some more on this table once I get the head mounted and all that. So, but anyway, I just wanted to celebrate this. This milestone. And next, we need to get the head mounted. Woohoo! Okay, that's all for today. I hope you enjoyed that. Yesterday was Thanksgiving here in the United States. I'd like to thank all of you viewers for sticking with me through this crazy project. I'm very thankful for my family, for my country, all the many good things. There's a lot of bad stuff going around in the world, and I think we don't take enough time to just remember all the good things that we have. So from my family to yours, I hope you had a good Thanksgiving as we go into the holiday season. All right, come back next time for some more. Thumbs up and comments are always appreciated. Thanks. Peace out.